This is Surd. Under Surd, we'll be looking at rules of Surd, basic form of Surd, similar Surd, conjugate Surd, and then Surds rationalization. Okay, this is powered by Brain Hub Academy by Kenneth Michael. We have other topics. Ensure you subscribe so that new video drops, you'll be able to see those videos that will be dropping. Okay, then apart from that, let's get into the work. Yeah, the topic is Surd. Now, what is Surd? Surds are irrational numbers. They are root of rational numbers whose value cannot be expressed as exact fractions. E.g., we have root 2, root 7, root 12, root 18, etc. These are surds. So surds are irrational numbers. Okay, they are number that cannot be rationalized. Okay, they cannot be rationalized. We have some rules of surds. Now, the first rule is that root of p times q, that is pq, p times q, is also the same thing as root of p times root of q. So if you have a two value multiplied by itself with a single square root or root, you discover that you can split the root for them, the square root for them. And the next one is root 2, which is division. Root of p divided by q is the same thing as root of p all over root of q. You can split the root for the numerator and the denominator and it still goes. Then the root 3, you have root of p plus q. Now the single root of p plus q is not equals to root of p plus root of q. Now this the right hand side is not equals to the left hand side. So this can only work, single root can only be split between product of two number and division of two number when two number are being divided. Then the last one, rule 4, single root of p minus q is not equals to root of p minus root of q. It can be split like that. So these two cases, take note of them, and also these cases, take note of them too. All right, we have basic forms of fractions. Now, root of p is said to be in its basic form if p does not have a factor that is a perfect square. Now, thus, root p will only be basic if root p cannot be broken down further into two factors where one of them has an exact square root, e.g., root of 6, root of 5, root of 7, root of 2, root of 3 are all in basic form. Okay, so now here root 8 is not in basic form because it can be broken into root of 9 times 2. Therefore, root 18 is equals to 9 times 2, which is equals to, applying the first rule, you can split the square root. So root of 9 times 2 is still the same thing as root of 9 times root of 2. This is equals to square root of 9 is 3 times the square root of 2 is irrational. So we leave it like that. So this answer is equal to 3 root 2. But 3 root 2 is now in its basic form. So when we say write a surd in its basic form, we are saying that surd should be reduced to a point where it can no longer have a number that you can split that single number into, and you can be able to find a square root of one of them. So root 18 is not in a basic form because it can be split into 9 times 2 and we can find the square root of 9. But root 2 is a basic form. Why? Because it can't split these two into any number you can find the square root. Okay, we have similar. The next one is Similar sword. A similar sword. Swords are similar if their irrational parts contain the same numerals. Okay, e.g., 3 root n and 5 root n implies that root n is equals to root n. Okay, but 5 root 2 and 2 root 5 are not similar because root 2 is not equals to root 5. So we said similar sword, two sword will be similar if their irrational part is the same. So you discover that 3 root n and 5 root n, their irrational part is root n. The irrational part of 5 here of this side is also root n. So the root n here has root n, here has root n, so therefore they are similar irrespective of the rational part that is outside. If the irrational part are the same, then they are similar. Okay, so that is what we have. All right, now let's look at example. Example 1, we have simplify root 45 and then b root 98. If you are simplifying, we are saying that reduce to the basic 10. Simplify means reduce this all to its basic terms. Okay, look at it. We have root 45. Root 45 can be, split into root of 9 times 5 because 9 times 5 is 45. So you split according to the rule 1 of sword. You split. This multiplication, the terms can be, the root can be split between the terms. So this is equals to root 9 times root 5, which is the same thing as root 9 is 3. Square root of 9 is 3, then square root of 5 is an irrational number. So therefore, this answer is going to be 3 times square root of 5. So we leave it like that. It's already in its basic form. It's equals to 3 times root 9, which is 3 times root 5, which is the same thing as 3 root 5. Alright, the B part, root 98. Root 98 is the same thing as root of 49 times 2. 49 times 2 will give you 98. So split the square root. The square root of 49 times square root of 2 is equals to square root of 49 is 7. And then times root of 2. 7 times root 2 is the same thing as 7 root 2. Alright, so example 2. Express the following as single sword. Single sword. We want to express all of this now. If we want to express it as a single sword. Now, this thing is not a single sword. It's not a single sword. Remember, we have a single sword need to be, there is no any need of a whole number, standing before the sword. So you need to take this whole number and make sure that the square root is covering all of them. You have expressed it as a single sword. So 2 root 5. 2 root 5 is the same thing as 2 times root 5. Yes. Because in between 2 and root 5 here there is multiplication. Okay, so this is the same thing as if you introduce square roots to 2 now, you discover that you need to introduce square because this square is the only thing that can cancel square root. So this root of 2 raised to power 2 is still the same thing as this 2 because this square can cancel the square root. You are left with only 2. So this is the same thing as 2 raised to power 2 is now 4. So you have square root of 4 times root 5. According to the first law of multiplication and law of sword, discover that these two swords can be merged and a single square root can be given to them. We have 4 times 5, so we merge their square root or their root and you have it now. So square root of 4 times 5, we have 4 times 5 is 20, which is square root of 20. You discover that we have succeeded in making 2 root 5 a single sword, and that single sword is root 20. The same thing happened here, 17 root 2. This is the same thing as square root of 17 raised to power 2. Okay, this is times this square root of 2. So square root of 17 square will give us 289. Then the square root to be square root of 289 times square root of 2. This 2 is what we bring here. So therefore, we can merge them with a single square root now. So 289 times 2, all of them is in a single square root. So if you multiply 289 times 2, it will give you 578. All of them is a single square root. So we have succeeded in making 17 root 2 to become a single sword. All right, example 3. As example 3 here, evaluate. Example 3 says evaluate a square root of 232 plus 3 root 8, and b 7 root 3 minus 17 root 75 rather, c 3 root 48 minus 40 minus root of 45 plus 2 root 12. So let's solve them one after the other. How do we evaluate this? Reduce them to the basic form. Evaluate means reduce to the basic form. So therefore, root of 32 plus 3 root 8 is the same thing as equals to, by the time you split this, 32 is also the same thing as 16 times 2. 16 times 2 will give you 32. That is why why we split it here. Plus 3 root, you can split 8 too. 4 times 2 will give you 8. So therefore, this is going to be equals to root of 16 will be 4. So the 4 will come out. The irrational part, which is the 2, will be inside. 16 is the rational part. 2 is irrational. Why 16 is rational? Because we can find the square root of 16, which is 4. It will now come out. The square root won't cover it again. Then therefore, we are left with only 2, which will take the square root alone. Then plus the same thing happen here. Square root of 2 is 2. So this 3 that is here is this 3 times this 2. You discover that we have square root of 2 left over because it's irrational. Then 4 root 2 is what we bring down, plus 3 times 2 give us this 6 square root of 2. We bring this root 2 down. So therefore, remember, we said two swords can be equal. Two swords can be equal if their irrational part are the same. The irrational part here is 2. The irrational part here is 2. So therefore, we can treat these two swords, 4 root 2 and 6 root 2, as similar swords. So since they are similar swords, therefore we can pick their rational part. The rational part of this is 4, the rational part of this is 6. So we can add them together and pick one of the irrational parts. Since the two irrational parts are the same, we can pick only one of them. So 4 plus 6 is what we have here. Then pick any of these irrational parts, root 2. 4 plus 6 is 10 root 2. So you see, we have expressed this sword to its basic form. Okay, so the second part now, we have 7 root 3. So 7 root 3 minus 75 root of 75. So 7 root 3 is what we bring. There is something we can do here. Minus 75 is the same thing as 25 times 3. 25 times 3 gives you 75. So therefore, the root of 75, we can 25 is rational. Okay, but 3 is not, it's irrational. So therefore, 7 root 3, we bring it down, minus square root of 25 is 5. Root the irrational, which is 3, we bring it down. So look at root 3 here and root 3 here. So since the irrational part are the same, these two swords, 7 root 3 and 5 root 3, are similar. So we can pick the root 3, any of the root 3, then treat 7 and 5. So 7 minus 5 is what we have here, root 3. 7 minus 5 is 2, then root 3. Okay. Then the next example we have here is 3 root 47. 3 root 47. 3 root 47. Sorry, 3 root 48 minus root 45 plus 2 root 12. So the same procedure goes again. We have to split this. 3 root is the same thing as 3 root 16 times 3. 16 times 3 is 48. Minus 75 is 25 times 3. Then plus 2 root 12 can be split into 4 times 3. Okay, so now you discover that we can find the square root of 16. Square root of 16 is 4. Then root 3, because we can't find the square root of these 3. So we bring it down. Minus square root of 25 is 5. Root this 3 plus 2, this 2, times square root of 4 is this 2. Then root the remaining part, which is 3. Then 3 times 4 is 12. root this 3 minus 5 root 3 is what we bring down here, plus 4. 2 times 2 is 4, then root this 3. Then look at this is root 3, this is root 3, this is root 3. So they are similar, so we can pick any one of them and treat their rational part. Okay, we can treat the rational part. So 12 minus 5 plus 4 is what we have here, root 3. 12 minus 5 plus 4 is 11 root 3. So 11 root 3 is what we have right now. Okay, so the next example, you discover that this next example now, we are asked to simplify root 45 times root 28. Then this have to do with division, root 24 all over root 50. Also root 60 times root 180. Root 180. Okay, so now then the next one is all over root 60 times root 180 all over root 75. Solution. So if you are solving this, root 45 times root 28, you discover that we can, do this within the process we know before. Root 45 is the same thing as 9 times 5, root of 9 times 5. Or the same thing, root 28 is the same thing as root of 4 times 7. So, because 9 times 5 will give you 45, 4 times 7 will give you 28. So this is going to be equals to square root of 9 is 3. Then we can't find the square root of 5, so we have it there. Times square root of 4 is 2. Square root of 7 cannot be found. It's irrational, so we have it there. So we have 5 and we have 7. So these two particular surds, you discover that they are not similar, but there's something we can still do to it. So we can treat the rational part 3 times 2, and then use these ones and multiply by themselves. Square root of 5 times square root of 7, 5 times 7 will give us 35. Okay, so 3 times 2 will give us 6, so we have 6 times root of 35. Alright, now root of 24 over root of 50 is the same thing as single square root of 24 over 50. It's the same thing. If you can reduce this, actually. 2 into 24 is 12 times. 2 into 50 is 25. So square root of this 12 can also be split into 4 times 3. 4 times 3 will give you 12. So it's going to be square root of 4 times 3 all over square root of 25. So square root of 4 is 2. Square root of 3 is irrational, so we repeat it down all over. Square root of 25 is 5. So the answer is 2 root 3 over 5. Also, we have similar example here where we have root of 60 times root of 180 all over 75. This is the same thing. This is equals to, you can merge this two square root to become a single square root. That's what we did here. 60 times 180 all in square root all over 75. This is the same thing as, since they are dividing another rule, the quotient rule of surd says that you can make this numerator root square root and the denominator square root to become single. So if 60 times 180 is 10,800 all over 75, all of them in single square root. So divide 10,800 all over 75. If you have your calculator, you can check. Discover that is 144. Square root of 144 will give you 12. Press it in your calculator and see. You are going to have 12. Okay, you are going to have 12.